All right, so as we look at 24, again, we are dealing with the same directions, graph the compound inequality, and we're given 3x plus 2y is greater than 4, or x is greater than 2. And this is the first compound inequality where we've been given that has or separating the two inequalities. And we'll talk about that a little bit more towards the end. But first, let's go ahead and graph each of these inequalities on our grid. And hopefully you'll recall by now what we're going to do is take this first inequality, 3x plus 2y, and instead of using this inequality, let's go ahead and just switch that over to an equal sign just for the purposes of graphing. All right, and we can do a couple of things here, right? We can either solve for our x and y intercepts, or we can choose two other points by choosing values for x and y, or we can put this into y equals mx plus b, and that's usually what I like to do. So we'll go ahead and do that by subtracting 3x from both sides, and that leaves us with 2y is equal to negative 3x plus 4, and then finally solving for y, we'll divide by 2 on both sides, and that's going to leave us with y equals negative 3 over 2x, and then positive 4 divided by positive 2 comes out nicely as just a plus 2. All right, so now that we have y equals negative 3 over 2x plus 2, we know how to graph this, right? We're going to go to 2 on the y-axis, graph that point, and then from that point we're going to use our slope, which in this case is negative 3 over 2, to find out what our next point on this graph is. So starting at the y-axis, or y-intercept rather, of 2, we're going to go down 3 units. So 1, 2, 3, and over 2, 1, 2. And there's our next point. And we can, again, do that an infinite number of times. So 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. But we don't have to, right? Because we only need 2 points to graph a line. But sometimes it's nice to have a few on the grid there. And we're going to go back before we connect these dots to our inequality and find out what kind of line are we using, a solid or a dotted. And in this case, since we're dealing with a greater than, we're going to be using a dotted line. So let's see if I can put a dotted line. All right, that looks decent enough, right? We're not artists, right? So it doesn't have to be perfect, just so we have an idea. All right, and now we want to determine whether or not we're shading on the below this line or above the line. And so let's go ahead and choose a test point. And again, we like choosing that origin, that test point of 0, 0. So long as your line doesn't go through that point, that's a pretty good point to choose. So 0, 0, and that's our x, that's our y. And we're going to take that point, plug it into the original inequality, and test to see whether or not we get a true or false statement. So let's go ahead and do that. So we're going to have 3, and then plugging 0 in for x, plus 2, plugging 0 in for y, is greater than 4. 3 times 0, well, that's just 0, plus 2 times 0, well, that's 0, so that's 0, is greater than 4. Well, 0 plus 0 is greater than 4. Is this a true statement or false statement? Is 0 greater than 4? Well, no, that's a false statement, isn't it? And so since that point that we chose to test was below the line, that means any point below this line will also give us a false statement, and we only shade on the side of the line where the points are true. And if the points below the line are false, that means the points above the line are true. So that's where we shade above. All right, so now let's go ahead and graph this next inequality. Our x is greater than or just simply greater than 2. And again, for the purposes of just graphing, we're going to pretend that is x equals 2. And we know how to graph x equals 2. That's simply a horizontal line passing through the x-axis at positive 2. And what kind of line is this? Solid or dashed? Again, it's going to be dotted or dashed. So let's go ahead, oops, that's not a very good start. Let's go ahead and make that dotted line, a horizontal line, or vertical line rather, excuse me. I might have been saying horizontal. Obviously this is a vertical line here. All right, and now that we've graphed this inequality, let's go ahead and determine whether or not we're shading on the left-hand side of the green or the right-hand side of the green. And we're going to go back to our original inequality, x is greater than 2, to determine that. So this is asking where are all the x values, so the x values on this x-axis, that are greater than 2. Are they to the left of the green line or to the right? Well, we clearly know that all of the values of x that are greater than 2 are to the right, right? We have 3, 4, 5, 6, 7. Those are greater than 2 versus 1, 0, -1, -2. Those are all less than 2. So we want to shade to the right of this green line. All right, there we have it. And now that we've graphed both of these inequalities and shaded, we want to go back to the original statement here and find the word separating the two inequalities, and that's going to tell us whether or not we have additional shading to do. And in this case, because the word is or, we know that we are complete. We don't have to go back and make sure that the double shaded portion is darker. When the or is separating your two inequalities, whatever portion of your graph is shaded, whether it's single shaded or double shaded, is the answer. So when that or is separating any portion of your graph that's shaded, any portion of the graph that's shaded is your answer. All right, so we don't have to go back and do anything additional. We can leave it just as it is and move on to number 25.